All right, so let's try example 6 here. We're gonna find the derivative of this function using chain rule, but other rules as well. So in this example, we can, if we can point out here that the outside function for this happens to be again a power function, right? With the inside, right, of this. Now this inside happens to be a quotient. So along the way, I'm gonna promise you that we're gonna have to do a quotient rule. All right. So let me write down here real quick our um, if we had a function using power, the general power rule, right? Then we do the derivative of the outside, leaving the inside as it is. Take away one from the power, and then multiply by the derivative of the inside, right? Okay. So let's go ahead and do that. The derivative of this according to this, is bring down the power, leave the inside as it is, take away 1 from the power, and then don't forget to multiply by the derivative of the inside, right? That's how it looks like. So at this point now we're going to write the inside of this. X plus 5 over x plus 6, x plus 5 over x plus 6, right? So this is technically, we just used the chain rule, right? Technically, you just found the derivative, but it is sort of almost incomplete because we sort of kind of make a promise. Hey, we promise to do the derivative of this in a second, right? In the next step. So, so that itself is going to require for us to think about which rule we need, right? Because we have a function over a function, that means we need the quotient rule. So let me rewrite the quotient rule here just so that we can have it. Okay, so following that, we're gonna rewrite everything else, right? Everything else stays the same. And then when we multiply this, we're gonna multiply this but to the whole thing, right? So it'll be this big fraction bar. And I'm gonna sort of do this extra setup, right? There you go, right? So if you see how I just focus, my focus was this part right here, finding the derivative of this. The derivative of this is this whole thing. The other part right here was just carried over because it was just it was already done, right? All right, so let's go ahead and simplify this. This stays the same. All we're doing is taking the derivative of x plus 5, which is just 1, right? Derivative of x is 1, the derivative of 5 is 0, so that's 1 times x plus 6. That one stays the same. The derivative of x plus 6, well, derivative of x is 1, derivative of 6 is 0, so you just have 1 plus 0, which is 1. And then x plus 6 squared. And then we can see that this is just 1, so we can combine pretty much and simplify this whole thing. So we need to distribute this negative. So it'll be negative x minus negative 5 or minus 5. You can just leave the square on the bottom as a square. We don't have to actually do anything about that one. And combine like terms, those cancel each other out. So you have 6 and minus 5 gives you 1. And there you go. Right, we completed that part. And that is the derivative of the function. So at first it kind of seemed overwhelming, but let the rules talk to you, right? You gotta think about what we have in a big picture, and then think about setting it up, right? I've been very consistent on the setup, right? Just trying to set it up using kind of this idea, these formulas will help you guide you like what's the next step. A lot of times we get overwhelmed and want to do like 5 steps at the same time. I get it, right? I was there, but I suggest you to take one moment, take a step, try to set it up first. All right. Hope you guys find this helpful. Please let me know if you have